They both love me and they love me not. They both love me and they love me not. They both love me and they love me. Oh, I'm sorry. I was just playing with my Schrodinger flower. Don't you just love February? The month of flowers and hearts and chocolate and math. I just love all the math you can find around you in February, from the beautiful symmetry in a heart to finding the Fibonacci spiral in the center of that beautiful sunflower in your bouquet. Some mathematicians even make roses using sine and cosine functions. We can even calculate our age using the age-old Valentine's Day gift, chocolate. Want to try? First, pick a number that's more than 1, but less than 10, that indicates how much chocolate you'd like to eat per week. Then, because we know we all eat more chocolate than we should, multiply that number by 2. Then, to accommodate for Valentine's Day itself, let's add 5 more to this number. Now, let's multiply it all by 50 to cover the rest of the year. Now, we're going to add 1,750 to our answer. And then we're going to add the last 2 digits from the year you last had a birthday. So if your last birthday was in 2021, then you're going to add 21. If it was in 2022, then you'll add 22, and so on. Finally, we're going to subtract the year you were born. The first digit in your final answer now should be your chocolate number. And the last 2 digits should be your age. Here's mine. I like to eat 5 pieces of chocolate a week. Okay, I probably double that, so 2 times 5 is 10. And on Valentine's Day, I'll have at least 5 more pieces. So 10 plus 5 equals 15. Okay, now to cover the year, I'm going to take my 15 times 50 to give me 750. Next, we're going to add 1,750 plus the 750 to give 2,500. Then my last birthday was back in 2021, so 2,500 plus 21 is going to give me 2,521. Now I subtract the year I was born, which was 1980, to give me 2,521 minus 1980, or 541. The first number is my original chocolate number, 5, and the second is my age. But why does this work? It has to do with the fact that we pick a number, A, for our chocolate. Then we multiply by 2 to give us 2A. Then we add 5 to give 2A plus 5. Multiply both of these by 50 to give us 100A plus 250. Notice that I multiplied each piece individually. Now we're going to add 1,750 to give us 100A plus 1,750 plus 250, which gives us 100A plus 2,000. Now we're going to add the last 2 digits of the year you had your last birthday. I'm going to pick 21. This gives us 100A plus 2,000 plus 21, or 100A plus 2021. Well, that's the year I had my birthday in, my last birthday. So of course now if we subtract the year I was born, 1980, from the year I had my last birthday, we're going to get our age. Now, the tricky part is the 100A gives us our original chocolate number, but because we times it by 100, it moves the number into the hundreds place. So now when we add our age to it, we get 100 times A plus our age, or in my case, 541. Voila, our age by chocolate. Now, this is just a silly puzzle we do for fun, but mathematicians actually study problems like this all the time. They look at how do numbers relate to one another, what types of patterns can we find with them, and where do these patterns exist, and what can they tell us? Let's go back to our bouquet of flowers, and our sunflower in particular. The sunflower spiral in the middle actually contains a very famous sequence of numbers called the Fibonacci sequence. And it goes 1, 1, 2, 3, 5, 8, 13, 21, and so on. It actually continues on infinitely. Some people like to start the sequence with a 0 as well. It's created by adding the 2 previous numbers in the sequence together to get the next one. Now, it's attributed to Europe's Leonardo of Pisa, nicknamed Fibonacci, in the early 13th century. But it actually has roots much further back to about 200 BCE in India. The sequence is fascinating in nature, and it appears everywhere in nature. It's in pine cones, trees, rabbit breeding, flowers, and more. All of these patterns follow this famous sequence of numbers. And so mathematicians dedicate their lives to looking at numbers and patterns and how they relate to one another. And while our chocolate problem may not have any practical applications beyond having a bit of fun with numbers, sometimes that's what the joy and beauty of math is all about, looking for patterns and trying to find the amazing things that come out of them. So this February, or any time of the year actually, try to look for the beauty of math in the world around you. And to paraphrase the Beatles, remember, all you need is math.